Variation in household energy consumption. Energy demand for residential heating and domestic hot water use varies from one household to the next. To plan and model household energy demand therefore requires an understanding of how and why heating consumption varies. One of the most classic discussions is how much of the variation can be ascribed to occupants and buildings. Although it is simplified, such knowledge can contribute to better models and estimations, and thereby to better build environments and comfort in future buildings. But first, we need to look at the household and the consumption. Estimations show that 80% of heating consumption goes to space heating and 20% to domestic hot water, although the percentage for domestic hot water is higher in newer houses when compared to older ones. Showering, cleaning, hygge, cooking and so forth. Most of our everyday routines demand energy for heating and domestic hot water, but they do it in different ways. Taking a shorter or longer shower directly affects the energy used for domestic hot water, whereas cleaning, opening windows, hygge, comfortable relaxing time, having guests, etc., in a more indirect manner affect the indoor temperature and therefore the demand for residential heating. The energy demand of these routines often lives a quiet life in the shadow of more exciting aspects of life. For example, going to a football match, in the cinema, or even having a baby. Considering the complexity of residential heating demand and practices, estimating variation related to occupants and buildings can be beneficial. We investigated this using data from Denmark and the Netherlands from 2010 through to 2015. Using data on building characteristics, we can explain 27% in Denmark and 20% in the Netherlands of the variation in heating consumption. We assumed that for movers, that is when a house shifts occupants, or rather the occupants move, heating consumption change because of two factors. One is the occupants changing their heating consumption over time. We call this the time-dependent variation. Another is when the house gets new occupants, but the physical characteristics stay more or less the same. We call this the time-independent variation. For stayers, changes from one year to the next, that is from 2010 to 2015, is only a matter of the occupants changing heating consumption over time, so the time-dependent variation, for example due to weather differences like a colder or a warmer winter. When applying this movers and stayers method to the data from Denmark and the Netherlands, it seems that approximately 50% of the variation can be explained by differences related to occupants and 50% can be explained by buildings. If we look closer at occupant variation, we can see that it consists of normal changes in consumption from year to year, for example due to weather variations, price developments, etc., and that it changes due to occupants that move into a new house. This could be called new practices, or interactions between buildings and occupants. But this division between occupants and buildings also vary from house to house. For example, the influence of occupants seem larger when the building is more energy efficient and newer when compared to an older, less energy efficient house. These results suggest that it is unrealistic to aim for a building simulation model that perfectly estimates residential heating consumption for individual cases, and that households do not have exactly the same conditions and possibilities for responding to, for example, political interventions, new policy, and increasing prices. However, although the 50-50 divide is simplified, it can be a useful rule of thumb to build better models and estimations, thereby contributing to a better built environment and home comfort in the future.